A very good morning to all of you. This session we will discuss techniques of knowledge representation. So there are mainly four ways of knowledge representation, which are logic representation, semantic network representation, frame representation, production rules. We will discuss one by one. Now we will see logical representation. So logical representation is a formal language that is used in AI to represent knowledge without any ambiguity. So it follows a fixed set of rules and deals with the propositions to enable accurate reasoning and inference. So in logical representation, knowledge is expressed in the form of a logical statements, and here the conclusions can be drawn based on the rules and conditions. And every statement has a clear meaning that avoid confusions. So what is the need of this logical representation? To draw conclusions from a given facts, logical representation is required. And also it enables correct inference. And it allows the machine to reason logically similar to a human. And we can say that it supports communication of knowledge in a precise way. We will see syntax and semantics in a logical representation. So syntax defines the rules for forming valid sentence and how symbols, variables and operators can be combined. That will be defined with the syntax. So for example, if we have man Marcus, we have already seen that Marcus is a man, then its logical representation is man Marcus. So if you don't have, if you are not using this bracket, so if we are missing this, then that is the syntax is wrong. So syntactically it is wrong. So if you are using this bracket, then we can say that this is syntactically correct. Then semantics. So semantics means the meaning of the sentence, how the sentence are interpreted in the real world. So what does the sentence mean? So man Marcus means Marcus is a man. That is semantics. So logical representation supports better inference or correct inference. So if the promises are if the premises are true, then the conclusion derived is guaranteed to be true. So this makes the logic-based systems very reliable. Here, there are different types of logical representation, that is proposition logic and predicate logic. We will discuss both in detail in the later slides. So we can say that logical representation is precise and unambiguous, and it uses syntax and semantics, and also it supports sound inference. There are two types of logical representation, that is proposition logic and predicate logic, and that we will discuss in this chapter. We have already discussed this advantages of logical representation. It is precise and unambiguous and a strong reasoning capability and well-defined inference mechanisms. And the limitations are it is difficult to represent uncertain or incomplete knowledge and computationally expensive for large knowledge bases. The next is semantic networks. A semantic network it is a graphical knowledge representation technique in which knowledge is represented in the form of a network. And here we have nodes represents the object and concepts and also the entities, and the arc or link represent the relationship between objects. We will see the figure in the next slide. And this representation is inspired by the way human organize knowledge in the memory. And the semantic networks categorize the objects in different forms and can also link those objects. Semantic networks are easy to understand and can easily be extended. So here we can see the example. Here we can see these nodes, each node that represents the object, concepts or entities, and the arc or this link actually represents a relationship like is, a, has, owned, like that. So here we can see a given sentence are given. Jerry is a cat, cat is a mammal, Jerry is owned by Priya, Jerry is white colored, all mammals are animal. So here we can convert this into a semantic representation. Here, Jerry is a cat. So here we can represent Jerry as one node and cat is another node, and the relationship we can mark it as is a. Here you can see Jerry is a cat. And then cat is a mammal. There cat is an object and mammal is another object. And here we can mark it as the relationship we can mark it as is a. So cat is a mammal. Then Jerry is owned by Priya. So here Jerry is there. Then we can write another object as Priya and the relationship we can mark it as is owned by. And then Jerry is white color. Jerry is already there. Then it is a color is white. So we can mark the relation as is colored. And all mammals are animals. All mammals are animals. So mammals we can one object and animal is another object and their relationship is a. So all mammals are animals. This way, we can represent this simple sentence into a semantic representation. So, next we will see the advantages of semantic networks, and we have already seen semantic networks that can categorize objects into classes and subclasses. So that can link objects using different relationship and that support inheritance, and also it is easy to visualize and understand. So advantages, first one is they are natural representation of knowledge and meaning is conveyed in a transparent manner. And although it is easy to expand by adding new nodes and links. It is simple and it is user friendly and also it is useful for conceptual knowledge representation. And next we will see the drawbacks of semantic networks. First point is actually high computational cost at runtime due to network traversal. So that means if there is a one question is there, to find its answer, we have to traverse to the entire network. So if the tree is very large, or if that we have a very large information we have or very large knowledge base, then we have to traverse the entire tree. So then next point actually in this case itself, in worst case scenario, the entire network must be searched even if no solution exists. Then cannot practically model human memory scale. That is the second point. That is semantic networks are actually try to model human like memory, but in human there are 10 to the power 15 connections are there in human brain, but it is difficult to model that. So it is not practically possible. Then the third point is actually lack of quantifiers, such as for representing all, for some, none. It is difficult to represent all this. Then there is no standard definition for linked names. So we are in the previous slide we have seen it can be is colored, it can be leaves it like that. So there is no standard definition for linked names. Then networks are not intelligent by themselves and depend heavily on the system designer. So networks are not intelligent; they are depend on the creator of the system. So these are the drawbacks of semantic representation. So, so there are a main limitation is actually it cannot represent universal statement, that is all representation. Then some of none. So all this representation is not possible. So it is less powerful than the predicate logic. We will discuss predicate logic in detail. So semantic network is a graphical knowledge representation in which the nodes represent objects or concepts and arc represents the relationship between them. Next is frame representation. So frame is a structure record used to represent knowledge about an object, concept or a situation. So it describes an entity using a collection of attributes and their corresponding values. That is, we have already seen slots and fields. So in this table, you can see that slots and fields, that is fillers. So that means attributes and corresponding values. The frame representation is also known as slot filler knowledge representation in AI. So here a frame consists of frame name, that is an object or a concept. Then slot means attributes or properties of the object. And then fillers means values assigned to a slot. And default value means optional. And then next is the procedural attachments. That is also optional. That is action when a slot is accessed. So we will see the syntax and semantics of frame. Syntax actually defines how slots and values are written. So for example, here you can see manufacturer, General Motors, model, this one, Chevrolet Caprice, year. So this is the syntax and that defines what each slot and value means. Slot, here you can see engine indicates the type of the engine used and slot wheels indicates number of wheels. Then we can see the frame that is car. So we are considering the frame. Here the example is of a car, actually frame representation of a car. Here type is this one, color is this one, the engine, wheels, like that attributes we are selected and the corresponding values we are writing. So using inheritance, here if car is a subclass of vehicle, then car inherits common properties of vehicle. Vehicle may have the property wheels, engine type and fuel. So this reduces redundancy and improves the representation. Here we can see the example frame representation of a person. Here you can see name, age, gender, email are the attributes we have considered. Then we have a student frame. There we have is a roll number, program, department, year, CGPA. These are the attributes in the student. But the student frame inherits person frame. So here the student also we can write the attributes name, age, gender, email because it inherits person. And then you can see another frame student underscore Rahul. So there also we have is a name, roll number, program, department, year and CGPA. So here this student Rahul also that inherits the property of person. Here you can see that student Rahul has is a attribute, roll number, program, department, year, CGPA, all this from the student frame, and name name is from the person frame. So it inherits the person frame. So here the student is a subclass of vehicle, a person, and this student inherits the common properties such as name, age, gender, and email. So this reduces redundancy and improves the arrangements for organization. Now we will see the advantages and disadvantages of frame representation. So this frame representation that makes programming easier by grouping related data, and it is very flexible and also widely used in AI application. And it is third point is it is easy to add new slots for attributes or relation. And the fourth point is it supports default values and also the missing values handling is possible. And next is it is easy to understand and also it can easily visualize. So it supports inheritance property. And the disadvantages means the inference mechanism is weak and logical inference cannot be smoothly performed here. So it is highly generalized approach. So there is a poor handling for uncertainty and not suitable for a highly dynamic knowledge. So when compared to predicate logic, it is less powerful. So main here, it uses loads and fillers structure, and it supports inheritance. And we can say that a frame is a slot filler knowledge representation that describes an object using attributes and their corresponding values. Next is production rules. A production rule system is a type of knowledge-based system that works using if-then rules. So each rule has a condition and an action. So if condition, then corresponding action. It is widely used in AI for problem solving and decision making. So main components are, first one is set of production rules. So these are if then statement and that define the knowledge of the system. For example, if at a bus stop then and bus arrives, then action get to the bus. Then if on the bus and paid and there is an empty seat, then what will be the action? Sit down. Then if on the bus and unpaid, then what will be the action? Pay charges. If bus arrives at destination, then what will be the action? Get down from the bus. So it will be in that structure. So it contains information about the current state of the problem, and then rules can read from and write to the working memory, and also update working memory that may trigger other rules. So next is actually we have a recognize act cycle. So this is the process. This is a recognize act cycle. So this is the process the system follows repeatedly. Recognize means check which rule condition match the current state. So that is a checking whether it matches with any condition. The current state is matches with any condition. Then act. Act means fire the matching rule and carry out their action. So this cycle continues until no more rules can be fired. So sometimes multiple rules are eligible to fire at the same time. The group of rules is called a conflict set. So conflict set means a group of rules that is a group of conditions that may match with the current state. So in this situation, the agent need to select a rule from this set, and it is called a conflict resolution. The system must choose one rule to execute. The process of making this choice is called a conflict resolution. So we have already seen this example. If at stop, bus and bus arrives means get into the bus. If on the bus and paid at the empty seat, sit down. On the bus and unpaid means pay charge. If bus arrives at the destination, then we have to get down from the bus. Then we will see the advantages and disadvantages of production rules. The advantages means it's a natural language expression. Rules can be written in simple human readable way. And second advantages is rules are independent. You can easily add, remove or modify individual rules. And disadvantages means no learning capability. The system does not store past results for future uses. Second point is inefficiency. That is, many rules may be active at once, making the system slower during execution. So here actually we have seen the previous example, the bus case. So that is the best example of a recognize act cycle. So it will check the current condition matches with any of the rules, and if it is matched with a particular rule, then that corresponding action will be carried out. That is called a recognize act cycle. Thank you.